Skeleton is pioneering a new era for the digital revolution. Whether you're looking to develop a website, an Android app, iOS app, or a software to ease your workflow, you've found your best bet. Hello techies. Today we are going to talk about what are containers. But before we begin, do not forget to subscribe our channel and hit the bell icon for more interesting videos. What are containers? Containers provide a logical packaging technique for applications, allowing them to be separated from the environment in which they function. Regardless of whether the target environment is a private data center, the public cloud, or even a developer's own laptop, this decoupling allows container-based apps to be deployed easily and consistently. Containerization allows developers to concentrate on their application logic and dependencies, while IT operations teams may concentrate on deployment and management without having to worry about application details like exact software versions and configurations. Containers are frequently compared to virtual machines by those coming from virtualized environments, VMs. You may be aware of virtual machines, VMs, which are operating systems that run on top of a host operating system and provide virtualized access to the underlying hardware. Containers, like virtual machines, let you package your application with libraries and other dependencies, creating separate environments in which to operate your software services. The parallels end here, as you'll see below, as containers provide a significantly more lightweight unit for developers and IT ops teams to work with a slew of advantages. Unlike virtual machines, which virtualize the hardware stack, containers virtualize at the operating system level, with numerous containers running directly on top of the OS kernel. When compared to starting a whole OS, containers are significantly more lightweight. They share the OS kernel, start significantly faster, and utilize a fraction of the RAM. Consistent environment. Containers allow programmers to build predictable environments that are separate from other programs. Software dependencies, such as specific versions of programming language runtimes and other software libraries, can also be included in containers. All of this is assured to be consistent from the developer's perspective, regardless of where the application is deployed. All of this means developers and IT operations teams spend less time debugging and detecting variances in environments and more time delivering new functionality to users. It also means fewer bugs, because developers may now make assumptions in their development and testing environments. It also means fewer defects, because developers can now make assumptions in development and testing environments that will stay true in production. Run anywhere. Containers may run on Linux, Windows, and Mac operating systems, on virtual machines or bare metal, on a developer's machine or in on-premises data centers, and, of course, in the public cloud, substantially simplifying development and deployment. The widespread use of the Docker image format for containers aids portability even more. Containers can be used to run your applications wherever you desire. Isolation. Containers virtualize CPU, memory, storage, and network resources at the operating system level, giving developers a sandboxed view of the operating system that is logically isolated from other applications. To get to know more about tech-related topics, subscribe, like and share.